Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 8 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 3342. Find minimum time to reach last room 2. Okay. So yesterday we have solved part 1. Okay. And today we are going to solve part 2 of this problem. Let's read the problem statement first. There is a dungeon with n into m rooms arranged as a grid. You are given a 2D array move time of size n into m, where move time ij represents the minimum time in seconds when you can start moving to that room. You start from the room 00 at time t is equal to 0 and can move to an adjacent room. Moving between adjacent rooms takes 1 second for one move and 2 seconds for the next, alternating between the two. Okay. We have to return the minimum time to reach the room n minus 1 and m minus 1. Okay, last row. Two rooms are adjacent if they share a common wall either horizontally or vertically. Okay, so the only difference between part 2 and part 1 is this line. See this line. Moving between adjacent rooms takes 1 second for one move and 2 seconds for the next, alternating between the two. Okay, now see the part 1 problem. So here see, moving between adjacent rooms takes exactly 1 second. That's it. Okay, so here exactly 1 second, and here there is a parity that we need to check. Okay, so moving between adjacent rooms takes 1 second for one move, and then it is going to take 2 seconds for the next, and then again 1, then again 2. Okay, alternating between the two, right? So this is the extra thing that we need to check in part 2. All right, so I will try to write the same code, okay, same logic, but little bit we have to modify. Okay, we have to check the parity as well in this code. Okay, so let's get started, okay, from scratch, right? So here see this example number 1, right? So here this is move time. Okay, so here let me draw the rooms. So here m into n, first you have to calculate, so 2 into 2, right? Okay, so you are given a 2D array move time of size n into m. Okay, so n is 2 here and m is also 2, right? M is also 2, so just draw a grid of 2 into 2, right? So that's the first thing that we have to do. Okay, so let's suppose this is your grid. All right, and here this is nothing but 2 into 2. Okay, 2 into 2. All right, so here let's just give the indexing 0 1 and 0 1. This is nothing but 2 into 2. Okay, n into m. All right, and here what is the move time given to us? So 0 4 and then 4 and 4. Okay, so here 0, here 4, and here also 4, and here also 4. All right, so here we need to check two things, okay, with even parity and with odd parity. Okay, so initially let's suppose the time taken, okay, in this 0 0. Okay, so initially let's say it's infinity, and it is also infinity. Okay, here you can say parity with 0 and 1. Okay, so you can say consider like that. Okay, so with 0 parity and with 1 parity we have to check, right? So here you can say with 0 parity, okay, and with 1 parity. Okay, this also infinity time reach. Right now initially I will take say infinity only. Okay, with 0 and with 1. Okay, and same way here also infinity 0, and here also infinity 1. Okay, and here also infinity 0 and infinity 1. Okay, so this 0 and 1, it is nothing but the parity. Okay, for even odd move count we are going to check. So if in even number of counts we reach here, and if in odd number of counts we reach here, so based on that we have to update this value. Okay, so right now it is infinity in the starting. Okay, so now initially you are going to start from here. Okay, from this, right? So your source is nothing but 0 comma 0. Okay, you start from room 0 0 at time is equal to 0. Okay, 0 0 and at time is equal to 0. Okay, add time is equal to 0. Okay, so if time is 0 and you have taken just even number of steps, okay, even number of steps, so I'm going to change it to 0. Okay, this is nothing but a time. Okay, here this first value is nothing but time and second value is nothing but the parity. Okay, so here see, at time is equal to 0, you are starting from 0 0, and where you need to reach, you need to reach to the this cell. Okay, this cell, so this cell is nothing but 1 1, right? 1 1. Okay, so 1 1 is your destination. Okay, so in this destination you may reach in this 0 parity. Okay, and there may be some value here x, and you may reach in the 1 parity, and there may some value here y. Okay, instead of infinity, infinity is the starting point now, but we will update, we need the minimum, right? So from here, with 0 parity, let's suppose you are reaching in x, and with 1 parity you are reaching in y, so we have to just return the minimum of these two. Okay, math.min of these two. Okay, so now how we are going to get started here, so let's see. Okay, so first what you need to do here, create one priority queue just like yesterday. Okay, so let's suppose this is your priority queue. Okay, this is your priority queue. All right, and in this priority queue you are going to use main heap. Okay, and based on your first value, right, which is going to be the current time. Okay, so based on current time you are going to add the values in the main heap. Okay, so right now you are starting from here. Okay, so here 0. All right, and then you are, this is nothing but your current time. Okay, that you are passing, and initially you are at this row. Okay, and initially you are at this column, and initially you are with even number of steps, right? So here parity is 0 only, right? This is what you need to add. Okay, so this is your starting point. Okay, priority queues, right? And okay, so now from here you have to start. Okay, so from this I already explained. Okay, so from a particular cell you have 4 choices. Now you can go up, right? You can go down, you can go to the left side, right side, and you can go to the left side. Okay, these are the choices, right, from a particular cell, right? So here two rooms are adjacent if they share a common wall either horizontally or vertically. All right, so here let's suppose this is 0 0. Okay, this is 0 0. All right, so now if you are moving up, so from here to here you are moving, right? So here in up you see that your row, this is first row, this is 0, so your row value is decrementing by 1, right? So here I can say for up coordinates I can say -1 0, and here -1, and here your column is remain same. Okay, column is 0 only, so -1 comma 0. So this is nothing but your up coordinates. All right, up coordinates, up coordinates. Same way here if you move down, so let's suppose from 0 you are moving to 1. Okay, so here if you see your row is incrementing, so here you are going to write 1 and 0 as your down coordinates. Okay, down coordinates. Same way if you are moving to the right side. Okay, so 0 to 1, so here see these are columns now, column 0, column 1. Okay, right, this is columns, right? So here column value is incrementing, right? So when you are moving to the right side, so here 0 0, so here you are going to write 1, and here row is going to remain same. Okay, so your column values are incrementing. This is nothing but for right coordinates. Okay, right coordinate. And same way for left coordinates you have to write uh, see here from 1 to 0 you are moving. Okay, so column value decrementing. Okay, so here you can write 0 -1, so these are nothing but the left coordinates. Okay, so these are nothing but directions, right? So here initially if you see you are going to start from current time equal to 0, right? Just we have to run one while loop, right? And we are going to run this while loop until my main heap is empty. Okay, so first just poll this complete, so just poll this all this outside. Okay, now we are going to execute few things inside my while loop. Okay, so my current time is 0, row is 0, okay, column is 0, and parity is 0. Okay, parity is 0. All right, so from here you are in this cell, so from here you can move to this cell, you can move to this cell, you can move to this cell, you can move to this cell. Okay, but here this is not going to be the valid case. Okay, there is no cell here, boundary condition, there is no cell here, so this is also not going to be valid case for this particular cell. But you have choices, you can move to this right direction and you can move to the down direction. Okay, so now here see, uh, you are moving from this. Okay, currently parity is 0. Okay, so if you here you can say that if your parity is 0, right, if your parity is equal to 0, then you are going to consider the move cost as 1, otherwise you are going to consider the move cost as 2. Okay, so this is nothing but move cost, moving to the next cell. Okay, move cost, move cost. Okay, so this is your move cost. So right now it is 0. Okay, so from this we are moving, right, we have 0 steps, so now we are moving to the next adjacent cell. Okay, so if it is 0, we are going to consider 1 initially. Okay, this time, right. So now here, from here, if you can move to this. Okay, so if we are moving to this, so here what is the wait time given to us? So wait time is given to us as 4, right? So here you can create one variable, wait time. Okay, and in wait time you have to update like this, math.max of what is your current time is 0. Okay, and here what is the value of move time, the new x coordinate and the new y coordinate. Okay, so new x and new y coordinates are uh, this 0 and this 1. Okay, so new x coordinate is 0 and new y coordinate is 1. Okay, so previous x coordinate was 0, right, and y coordinates was 0. Okay, in the starting, right. So here you are moving to right. Okay, so in right, so 0 and 0, so for right you have to add 0 here, so you are going to get 0, and here you have to add 1 in the column sign. So here see, new x and new y are coming out as 0 and 1. Okay, so this is your initial coordinates x and y, and this you have to add this. Okay, for moving to the right direction. Okay, so you are adding, so here you are getting new x and new y, right. So here new x new y, so past 0 and 1 here, so this is nothing but 4. Okay, so here your wait time is 4, right, wait time value will come as 4. Okay, max 0 and 4, what is max? 4 is max, so wait time is coming as 4. Okay, so after 4 only you are going to move, right. So once this 4 happens, right, then you have to update the arrival time. Okay, and arrival time is nothing but it is going to be the wait time, which is nothing but 4, and after then you are going to move, right. So move cost is nothing but 2, this time 1. Okay, because your parity was 0, so if parity was 0, take it as 1, otherwise 2. Okay, so arrival time you are going to update it as 1 plus 4, that is nothing but 5. Okay, right, 5 is the arrival time, right. And the next parity, next time what parity we need to take. Okay, so next parity I will just update. Okay, so adjacent, now first we are, if we are taking this time 1, then next time we have to take 2, right, then we have to take 1, then we have to take 2. Okay, like this, right. So what we have to do here, next parity I will write it like this, 1 minus the current parity value. Okay, current parity value was 0, right. So next time it is going to be 1 minus 0 is equal to 1. Okay, so see here, if my parity is 0, then next time I'm taking 1 minus b, that is going to be 1. Okay, so if my parity is 1, okay, so then I'm taking 1 minus 1, so next time it is coming out as 0. Okay, so it is going to change every time, right, next parity. So simple, we have to use this 1 minus parity. Okay, so now here you see arrival time. Okay, so I am moving to this, so arrival time is nothing but coming out as 5. Okay, so 5 is less than the value at this coordinate. Okay, so time at, so here this 5 value is less than 5 is nothing but arrival time. Okay, arrival time is less than, here see the value of this time of new x coordinate, new y coordinate, and here next parity. Okay, so here see, so next new x new y value was 0 1, and what is the your next parity? Next parity is 1. Okay, next parity is going to be 1, right. So here you see at 0 1 1 0 1 0 1 and at 1. Okay, so what we have infinity. Okay, so here infinity, so 5 is less than infinity, yes, so I'm going to update this to 5. Okay, here I'm going to update this to 5, right? And next time I'm also going to mark okay, next time you can okay, so this is done, right? So next time I'm going to just add this, right? So here if you see you can write here 5, 5 is the current time, okay, to reach this cell. And here this new x and new y coordinate we have to pass. This is 0 and 1, so 0 and 1, and with but parity is 1. Okay, so next time I'm going to take this as parity. Okay, so this is what we need to pass, right? Okay, this is done, right? And okay, this is done. Now after that, okay, once this is done, now after that you can do one more thing. So this is done. Okay, so now from here, from this particular cell, okay, from here you can also move to this now, right? So here also you are going to move in, here it is 1. Okay, so in 1 only, because here you are starting from 0, right? So 0 0, and next time your new coordinates are going to be 1 comma 0. So here new x and new y value is going to be 1 comma 0 next time. Okay, I'm uh, taking this only as my current cell, right? For this we have to check all the neighbors now. This is not possible, this verb is not possible, this right, we consider it, okay, and we added that in the priority queue, and now we consider this down cell. Okay, so here again parity is equal to 0 only, from here only we are moving, right? So here we are going to take again 1, right? And then wait time we are going to calculate, arrival time we are going to calculate, next parity we are going to calculate, and then we have to pass the arrival time. So here it is infinity, so here we have to take again 1, 5, right? This one, and here we have to add 5, right? Same way. So here again you have to add, right? So 5, and now this time coordinates are, x coordinate is new x coordinate is 1, this is 0, and then this is with even parity, 1 parity, right? This is done. Okay, so now uh, you go here and you go here. Okay, so this is complete. Okay, this is done, right? So now from here you can check now this one, 510. Okay, so take this one first. Okay, so from here how many directions you can move? So you can move to up direction. Okay, you can move to right direction, you can move down this, and you can move this. Okay, so here these are the 4 possibilities, right? Okay, take this outside. Okay, so current time here if you see it is nothing but 5, and x coordinate is nothing but 1, y is nothing but 0, and your parity right now it is 1. Okay, so just remove it right from the top of your priority queue, right? So now for this okay, so here there are multiple directions, right? You can't move here in this, okay, boundary condition, you can't move here, and here so you see that you can move here and you can move up. Okay, so here let's say first you are trying to move to this direction. Okay, so here if you are moving to this direction, then your new x and new y is going to be 1 and 1. Okay, so new x is going to be 1 and new y is going to be 1, right? So in this 1 0, if you add this 0 1, you are going to get 1 1. Okay, right? 1 0, and here 0 1, so 1 and 1, so this is new x new y. Okay, so now here you are moving like this, right? So here okay, this is done. Now here move cost. Okay, so parity is 1. Okay, parity is not 0 this time, so you are going to take the move cost as 2, right? So your move cost is coming as 2 here. Your wait time is going to be math.max of current time is 5, and move time here it is given as 4 only, right? So you are going to consider this 5 only. Okay, wait time. So arrival time you are going to update it as uh, this move cost plus wait time, so 7, right? And your next parity is going to be uh, 1 minus parity value. Okay, 1 minus 1, so 0. All right, so here you are moving here to with 0, right? So here from here to here with 1, and from to here 0. Okay, so here this, here we are reaching in infinity, but right now we are reaching in 7. Okay, so I'm going to update this to 7, right? This I will update as 7. Okay, here 7 with 0, right? 0 parity, right? So how we are updating this? Arrival time is less than time of new x, new y, and new parity. Okay, so we are going to update it our time of new x, new y, and here next parity, okay, is equal to arrival time. So I am updating like this. Okay, so arrival time is coming out as 7. Okay, and then in the priority queue, what we are going to add in the priority queue, we are just going to add the arrival time. Okay, new arrival time. So new arrival time is nothing but here 7. Okay, so 7 is coming down here, and the coordinates. Okay, so new x and new y coordinates are 1 and 1. Okay, this is done. And here after that, the next parity is nothing but 0. Okay, so and 0 we are going to update, right? So this is done. All right, same way from here also you can move to the top. Okay, again you can move to the top. Okay, so here we have to check that case as well, right? So here what you need to do, same. Okay, same conditions. Okay, but this time your new x and new y is going to be 0 comma 0. Okay, 0 comma 0, and now move cost is going to come out as 2 only. Okay, and wait time, again here wait time is going to come as 5 only, right? And the arrival time is going to come out as 7, and next part is going to come out as 0 again. Okay, for moving up, right? But here see, uh, here next part is coming out as 0. Okay, so now at 0, right, at 0 it is already 0 minimum, but this time it is coming out as 7. Okay, so then you don't need to update anything. Okay, you don't need to add update any, because this condition is not satisfied. Now only if this condition is satisfied, then we are doing all this stuff, right? So you don't have to update any periodic queue. Okay, or this, right? So see here, 0 parity, then 1. Okay, and then 0. Okay, so we don't need to update, right? So and we are doing the alternate parities, right? So moving between adjacent rooms take 1 second for one move and 2 seconds for the next, alternating between the two, right? So here that's it. Okay, so this is done. Now this is for this cell. Okay, for now we have to consider this 5011. Okay, so here x is 0 and here y is 1. Okay, and here also parity is 1. Okay, so now remove this. Okay, remove this from top. Okay, and here now if you see, uh from here we have to move now. So from here we can move up this direction, right, down and left. Okay, so this is not possible, boundary condition. This is not possible, boundary condition. This is possible, downwards. Okay, so let's see if we can move downwards. Okay, so here if we move downwards, so that simply means the new x and new y coordinate is going to come out as 1 1. Okay, so new x and new y coordinate is nothing but 1 1. And now this your move cost, so parity was 1. Okay, from here, from this we are coming up, parity was 1. So now we have to check move cost is, we are going to take it as 2. And now this wait time we are going to consider this as 5, and here 4. Okay, max is 5, so we are going to consider this as 5, and the arrival time is going to come out as 7. Okay, and next parity is coming out 0. Okay, so here it is already 7. Okay, it's already 7 only, and 0 with 0, right? So we don't need to update. Okay, only when it is minimum. Okay, only when my arrival time is less than this. Okay, next new x, new y, and new parity. Okay, next parity. So here with 0 it is 7. Okay, so from here also, from top, if I'm moving down again, it is coming out 7. So we don't need to do anything. Okay, so we don't need to add anything. Okay, so from here there is also one case now, if we can add this. So here same now, with 0 you are starting, and here you are reaching in 1. Okay, and then again 0 you have to update. Okay, same like this cell, right? Again you don't need to update, because here it is 0 only. Again you are going to get your value of arrival time as 7 only. Okay, from here also, if you move to this direction, okay, 40 only, but it is already minimum, so though you don't need to update. Okay, that's it. So we have covered all the cases. Now only thing left out in the periodic queue is 7110. Okay, so now again take this. So here update this to 7 and update this to 1. Okay, and this is 1, and this parity is 0. All right, so this is done. Okay, so now here new x and new y. Okay, so for this we need to check. Okay, so from here you can move to this, you can move this, you can move here, you can move here, cancel out this, cancel out this boundary conditions, so you can move up. Okay, and you can move to the this direction. Okay, so now from here if you move up, okay, from here if you move up, then the coordinates are nothing but 0 and 1. Okay, so new x and new y is 0 and here it is 1. Okay, so 0 1, you are moving up, right? So here again move cost, so parity is 0, so you are going to take the move cost as 1 this time. Okay, and your wait time is going to be max of 7, and the move time, okay, so here it is 4 and 7, but it's max, so you're going to take 7, right? Maximum 1 only, right? So here you are taking the 7. Okay, and then arrival time is 7 plus 1 8, and your next parity is going to be 1 minus 0. Okay, so it is going to be 1. Okay, 1. All right, so here you are adding 1. All right, so here you see in 1, in 1, okay, you are moving back, okay, with the value at arrival time is 8. Okay, 8, right? And here it is 5 now, no need to operate, right? So see, from 1 you change it to 0, and from 0 you are moving back with 1. Okay, so at the same time we have to use, right, 1 parity. So in 0 you update, from 0 you have to update again 1. Okay, so here see, next parity is 1, and in 1 we are updating the arrival time 8. 8 we are updating, here it is 5 now, so why do we need to update? Okay, and same way now remove this also. Now we are checking this case only, right? So now from here also check this cell. Okay, so if we are moving to the this, right, 1 and 0. Okay, so 1 and 0, new x and new y is nothing but 1 and 0. Okay, so here this is 1 and this is 0, right? So 1 and 0. So now again move cost, again if you move to this position, okay, so it is going to be 1, wait time is going to be 7 only, right? And arrival time is 8, and expect is 1. Okay, so here also see, in 1 we have 5 now, but here arrival time is coming out as 8. So do we need to update this? No, we don't need to update. Okay, so that's it. So now this is ends. Okay, so see here my priority queue is empty. Okay, my priority queue is empty, right? There is nothing inside this priority queue. Now we have to stop. So now in the end, here see, at 0 and 1 we have 7 here and we have infinity here, so we have to return the minimum. Okay, here I have written a minimum, right? So here minimum is coming out 7, so that is going to be my output. Okay, so that's what we need to do, right, for this problem. Okay, so now let's write the code is also going to be very similar to the yesterday's problem. Okay, part 1. So I will also add that video in the description, right? You can solve that first if you haven't solved it, that video. Okay, that is very easy as compared to this one, because here we are checking this additional logic, right? 1 taking 1 or 2. Okay, but in that we are only using 1, right, every time. So let's write the code. So let me just maximize the screen. All right, so here first you have to calculate the n and m value. So int n is equal to move time dot length, and m value is move time, take first row and just calculate the length, so it is going to give you the column length. Okay, done. Then after that you have to take one time 3D array. Okay, 3D array we are going to use. So here new int, we are going to pass n, we are going to pass m, and this time we have to consider the parities as well, right? So here we have 0 parity and 1. Okay, odd even parity. Okay, so 2, right? So here what we are going to pass here in time, we are going to pass time I value, okay, j value, and here we are going to pass 0 or 1. Okay, for even odd move count. Okay, for even odd move count, right? Done. So now we have to fill this, all these values. Okay, so initially we are going to fill all these as infinity, 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 infinity. Okay, so we are going to update like that. right? And here we have to fill 0 1, sorry, 0 1 0 1. Okay, so this is what we need to do. Okay, and all other we are going to fill infinity infinity. Okay, so here what you need to do, run loops. Okay, for int I is equal to 0 and I is less than n, and here I plus plus. Okay, and here for int j is equal to 0, j is less than m, j plus plus. All right, and here after that you have to run one more loop, int k is equal to 0, uh, k is less than 2. Okay, and here k plus plus. All right, and here you have to update your time I, j and k. Okay, and here you are going to set all the values to integer dot max underscore value. Okay, right, here it is j. Okay, 0 0 I j. Okay, this small j. Okay, so here you can say, you can write it like this, or you can also write like this. Okay, so here 0 and 0, so for 0 take infinity, for 1 take infinity. Okay, here also, instead here just for simplicity I'm writing it like this for 0 and 1, but here you can say like this, at 0 1, and here if we have 0 then take infinity, and 1 for that take infinity. Okay, here also 0 take infinity, 1 take infinity. Okay, here also 0 take infinity and 1 take infinity. Okay, so 0 0, so here see I is 0, j is 0, then k 0, for 0 also infinity, and for 1 also infinity. Okay, so this is what, and then we have to update to 0. Okay, 0 0. All right, so that's a simple meaning. Okay, so here for 0 this, for 1 this, for 0 this. Okay, this is what I'm doing, right? Clear? Okay, so this is done. This is where my file for loop ends, and then you have to take one priority queue, right? So here priority queue, and in this priority queue you have to add the array, right? Int priority queue is equal to new priority queue. Okay, and here you have to use min heap, right? So here you have to pass this comparator, right? Comparator, just like yesterday's problem. Okay, comparator dot comparing int. Okay, based on the first value, right? Comparing int, and here you have to write a of 0. Okay, pass parameter, any parameter a, so based on this first value. Okay, the value at 0 index, so you have to use min heap. Okay, so that's it. All right, so now after that, in the priority queue, in the starting you have to pass 0 0 0 0, right? That is nothing but current time, row and column and parity. Okay, before starting. Okay, we are starting from 0 only, with 0 number of steps, right? So that is why from 0, right? So here current time 0, uh, row 0, column 0. Okay, and parity 0. Okay, done. So here let me add the comment as well. uh, Current time, row, column and parity. That's it. All right, and here starting from 0 0 0, so we have to update to 0, right? So this one, so here you have to write a time at 0 row, 0 column, and in that 0 parity. Okay, so here update it to 0. That's it. Okay, so this is the initial setup, and also add the directions as well. Okay, -1 0 0 1 1 0 0 -1. Okay, or add all these directions as well. So here you have to write int directions is equal to, here inside this you have to pass -1 comma 0. Okay, and then you have to pass 1 comma 0, then you have to pass 0 comma -1, and then you have to pass 0 comma 1. All right, so this is done. So here let me just add up, down, then we are adding left, okay, and then we are adding right. Okay, this is done, right? So this is basic setup. Okay, now we have to just run one while loop like yesterday. So while my priority queue is not empty, all right, so here inside this we have to check, we have to first poll this. Okay, so cur is equal to pq dot poll, right? So what we are getting here, we are getting current time, we are getting x value, y value, and parity value, right? So here just create one very few variables. Int cur time is equal to cur of 0, right? X is equal to cur of 1, y is equal to cur of 2, and your parity is equal to cur of 3. Okay, that's it. Okay, this is done. Now after that you have to check in all the directions. Okay, all 4 directions. Okay, so int here run for each loop for int d in all directions. All right, and here inside this your new x coordinate and new y coordinate you need to take. So new x is nothing but x plus d of 0, right? And new y is nothing but y plus d of 1, right? Okay, now here just check one boundary condition. If your new x, it should be greater than equal to 0. Okay, and your new y also, it should be greater than equal to 0, and your new x value, it should be less than n, and your new value, it should be less than your m. Okay, so here if this is valid, okay, if the salary is valid, then you have to calculate the move costs, wait time, arrival time, next parity, okay, all that stuff. So here how we are calculating the move cost first. So move cost we are going to calculate is like this. Okay, so if we are going to check if the current parity value, okay, if it is equal to 0, then we have to consider 1, otherwise we have to consider 2. Okay, so this is how we are going to calculate the parity. Now wait time. So wait time, how we are going to calculate? So wait time is nothing but math dot max of current time. Okay, so here current time, and here you have to write move time, and here you have to pass new x value, new y value. Okay, and this is how you are going to get the wait time, right? So this is done, and then after that arrival time you have to calculate. Int arrival time is equal to wait time plus move cost, and then the next parity you have to calculate. Next parity is equal to 1 minus parity, and then here only if your arrival time value is less than time of new x, okay, new y, and next parity, only then you have to update. Okay, and update the priority queue. Okay, only if this condition is satisfied, right? So here if this is the case, then just update this time nx ny and new parity, next parity with arrival time. Okay, and then in the priority queue just add this. Okay, priority queue dot offer new int. Okay, and here inside this you have to pass arrival time, new x value, new y value, and the next parity value. Okay, next time what is the parity you are going to use? Okay, next parity. All right, so this is done. Now that's it, right? And in the end, just return math dot min of, and here you have to pass time n minus 1, okay, m minus 1, and with 0 and with 1. Okay, two things you have to check. Okay, so here with 0, and here just copy this same thing, okay, and paste it here, and with 1 this time. All right, so now let's run the code and see if there are any code issues. We'll try to fix that. So see, all the test cases has been accepted, right? So now let's submit it. So see, our solution is accepted, right? So here, what is going to be my time complexity? So since we are using this priority queue, right, and in priority queue we are adding the values, right? So and we are removing the elements pq.poll, pq.offer. So for this poll and offer, the time complexity is log of your n into m. Okay, so right, so you are going to say that your time complexity is of n into m log n into m plus here of n into m into 2. Okay, so I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.